Welcome back, guys. This is question 5.54, and the statement of this question is: according to a study published by a group of University of Massachusetts sociologists, about two-thirds, okay, let me underline it, two-thirds of the 20 million persons in this country who take Valium are women. Assuming this figure to be a valid estimate, find the probability that on a given day the fifth prescription written by a doctor for Valium is A, the first prescribing Valium for a woman, and B, the third prescribing Valium for a woman. Okay, so in this question, what do we have to do? We have to use our developed concepts regarding the probability distribution to see that which probability distribution will be valid here. Okay, so in part A of this question, we can very clearly see that the fifth one will be the first one. Okay, so this can be translated like that the events have been done unless and until we have get the success. Okay, so this is part A. Let me write here. Okay, so solving part A of my question, we can very clearly see that this is what. Let me represent it by using this diagram, okay, in which we have 5 slots. Okay, and here this is the fifth one, and this fifth one is what? This is the first prescribing Valium for a woman. Okay, so means this is the first for this one, while all the others were not for the woman. So therefore the probability of it was what? The probability of it was 2/3. Okay, means this was 2/3, and all others were 1/3, 1/3, 1/3, and 1/3. Okay, so in finding the total probability of these independent events, we have to multiply them together, and ultimately we will get 1/3 raised to the power 4, 2/3 multiplying with it. Okay, so this is what? This is basically the representation related to the geometric probability. Okay, so the part first of A is related to the geometric probability. In part B, the third prescribing Valium for a woman. Okay, so it means that this is not the first one, while the third one is fixed, which is the fifth one. So that's why here we have to use what? Here we have to use the negative binomial distribution. Okay, so you have to keep in your mind that in geometric probability distribution, the last one is the first one, which is the success, while in the negative binomial distribution, there is not a fixed last one, which is the first one, while it can be any fixed number of the trial which has been done over this last trial. Okay, so let me again use the same representation for it. Okay, so there are 5 slots. Okay, this is the fifth one. This is 4, 3, 2, 1. Okay, this fifth one is what? This is basically the third prescribing Valium. Okay, means this is what? This is 2/3 probability. Okay, while these 4, out of them there can be 2 prescribing women, and the 2 non-women here would be here as well. Okay, so therefore what we can do here, these 2 can be anywhere here. So this is the combinatorial problem. So therefore we have to take all these 4, and out of these 4 we have to make the arrangements for the 2 prescribing Valium. Okay, the probability for the prescribing Valium are 2/3 raised to power 2. Okay, because 2 item will appear here, and the non-prescribing non-women item here will be 1/3, and those would also be 1/3, and here this 2/3, which is for this fifth item, will also be here. Okay, so writing it again here, it would be 4 choose 2. Okay, and this 2/3 multiplied by this 2/3, it would be 2/3 raised to the power 3 and 1/3. So this is what? This is the solution for part B of my question, which is related to the negative binomial distribution. Okay, so that's it for today, in which we have seen the relationship between the geometric probability and negative binomial distribution. If you have any question, You can ask me in the comment box. See you soon.